Okay, so today for section P5, kind of the zero chapter from the book, we're going to just review solving quadratic equations by hand. And we should be familiar with 4 different ways of doing this. Now, they don't all work all the time. Yeah, really the only thing that would always work all the time and not be a huge pain would probably be the quadratic formula. Factoring is easiest if it works, or square roots are really easy if they work. Completing the square will theoretically work for any quadratic equation, but sometimes the fractions get pretty intense. People don't like them, but there are certain quadratics we need. And completing the square we want to talk about, because without completing the square, we would not have the quadratic formula. So it's very important. I mean, completing the square is around a long time. Like they have clay tablets from Mesopotamia that describe how to complete the square. You know, it's old-timey. You know, so we should look at it. It's a good historical thing and useful. Okay, the first method that we want to talk about is factoring. Okay, this, if it works, is the easiest technique. You know, a lot of the time, just because it's just not too bad. It's just the math is pretty easy. Okay, so kind of the idea here is the first thing we do is we get the quadratic equal to 0. Now, all these are solving quadratic equations, right? So all these methods, we need an equal sign. Okay? We just did factoring, which there were no equal signs, right? It was just an expression that we broke into factors. So do be careful. Having an equal sign changes some things. It allows us to do other interesting things. It's important that you realize when you're factoring and you're going to finish with a bunch of factors like we just saw in the quiz you got back, versus when you're solving an equation where your answer is going to be x equals a number. So something really to kind of focus on as we move forward here. Okay, so the first thing we'll do is we'll get the quadratic equal to 0. Then we'll want to factor completely. And sometimes if you don't factor all the way completely, it still might work, but factoring completely will always be the probably best way to do that. Then we apply what's called the zero factor property. And that just says that if you have a product, A times B is equal to 0, then we know that either A or B must be equal to 0. Right? You multiply two numbers, you get 0 as your answer. One of those numbers had to be 0. We should say, though, A and B are real. If you have imaginary numbers, other things can happen there. But this is just for real numbers, which is what we're dealing with here. So that's basically how we solve by factoring. So the hard part is, can you factor it? Once you factor it, you set each factor equal to 0, you write your solutions. Okay, and again, a solution, we're trying to find the x's, like for this example, that make this expression true. Right, so I'm going to check each of those by plugging them into here at the end and make sure they equal 6. I'd recommend whenever you're checking, go back and check the most original form there, because in case you made a mistake on step 2, you don't want to check the wrong equation. So to solve this example here, we have 3x squared minus 11x equals -6. I'm going to go ahead and get 0 on one side. So that means I'm going to get everything on the left side here. I'm going to add 6 to both sides. 3x squared minus 11x plus 6 equals 0. It's important you write the equals 0. Really try to have equivalent facts written down the board, down your page. Okay, it's tempting to leave things off and think you'll remember them. And you might, but you might not. But this is mathematically pretty good here. So to factor this, we'd want to use split the middle. You could also probably guess and check. To factor it, let's say we want two numbers that multiply to be 18 and that add to be -11. So that would be -2 and -9. So let's see, 3x squared minus 2x minus 9x plus 6 equals 0. We'll factor by grouping. So x, 3x minus 2 minus 3, 3x minus 2 equals 0. And then you can either factor out the 3x plus 2, you can combine the front pieces, that's fine. X minus 3 and 3x minus 2 equals 0. Okay, now here at this point, it's factored, right? We've factored completely, it's equal to 0. We have two things that multiply together to equal 0. the zero factor property tells us then that x minus 3 equals 0, or 3x minus 2 equals 0. We solve these, we get x equals 3, or x equals 2/3, right? I just added 2 and divided by 3 there. So that should do it, right? Those should be our answers. If we go back and check those, hopefully they'd work. I'm feeling kind of lazy here, but let's see, that one's not bad. 27 minus 33 is negative 6. Let's see, this is a little tougher. That's probably isn't too bad. So let's see, 4 minus, let's see that. So that would be, check the other one here, 3 times 2/3 squared minus 11 times 2/3. Kind of not great looking. So we get 4/3 minus 22/3 is negative 18/3, which is negative 6. So it works. So that's solving by factoring. Now, your factoring could only be greatest common factor. You know, it could be your cubic rules, your sum of cubes, difference of cubes. It could be difference of two squares. It could be grouping, whatever. If you can factor it and have the equation equal to 0, you can solve it this way. If the equation is not equal to 0, this doesn't work. It's just not true. There's no like 5 factor property that if you multiply two numbers together and get 5, then one of them has to be 5. That's not a thing. So that's what we'll get. Okay, our next method here is to use square roots, or extract using square roots, you might hear it called. This is best when there's no bx term. Like, so we know it's kind of your general quadratic is ax squared plus bx plus c. If there's just a squared and there's no first power, this is by far the easiest method to use. Super easy. Sometimes even when you can factor, this might be a quicker method. Like if you have like, x squared or minus 4, you could use this method. So what we'll do here is really, we're just going to solve it like we used to solve two-step linear equations. We're going to isolate the x squared. Once it's isolated, we'll take the square root of both sides. The hardest part's remembering to put a plus or minus on one of the sides. You do that, you're done. People tend to leave one answer off here. So example 2 here is very straightforward. We have 7x squared equals 21. We're going to divide both sides by 7. So that's x squared equals 3. Okay, now to get rid of a squared, we know that we square root both sides. Remember though, when we are solving and we decide to take an even root, like as part of the solving process, we square root both sides, or we fourth root both sides, we have to put a plus or minus. That's the catch. Because all this is saying is some number times itself is 3. Well, we don't know if that number is positive or negative. Because if you do a negative times itself, you still get a positive answer. Or if you do a positive times itself, you still get a positive answer. So here we would say the square root of x squared equals plus or minus the square root of 3. And then so x is either going to be plus or minus radical 3. I would want you to just leave it as radical 3 in most cases. Kind of as the default. We like exact answers. If you need to know what decimal this is, it's easy to find out, but it's hard to go the other way. You can't get a decimal into a rational. All right, so that's kind of a very straightforward square root problem here. Example 2 is a little more involved, or example 3 is a little more involved here. And what we're going to do is take advantage of is here, we do have something being squared, correct? It's okay that it's an expression instead of just an x. It's fine. So like if you had a number out here, you'd want to divide it first like we did with the 7. But if we do get to something like this, we can at this point just take the square root of both sides. So we could say the square root of 2x minus 1 squared equals plus or minus the square root of 9. The squared and the square root cancel. So 2x minus 1 equals plus or minus 3, because the square root of 9 is 3. Here's where we have to be careful a little bit, is that it's pretty common for people to add 1 to the 3, get 4, divide by 2, and then write plus or minus 2, which is half right. It's not. You have to actually, at this point, you should probably split it into 2 equations, because they're going to look different. So here we get 2x minus 1 equals 3, or 2x minus 1 equals negative 3. So here we'll go ahead and add 1. We get x equals 2. Or here we get, when you add 1, you get 2x equals negative 2. Divide and you get x equals negative 1. So just because this was the plus and minus of the same number doesn't mean that's always going to happen. If you have a doubt, I would suggest you split it up into 2 equations. Right, remember, that's what the plus or minus means. You're just using it to represent 2 equations. If we check it, you get 3 squared. Yep. Negative. Yep, that'll work. So that's that one. Okay, our third method is completing the square. This is the first method that we've looked at that'll work for everything, right? Sometimes factoring, sometimes it doesn't factor. Or we know using square roots, if you have an x squared and an x, it's not going to go very well. Completing the square always works. It's really mathematically powerful, right? But it can be annoying and you have to deal with lots of fractions. So it's got that against it. The one thing I would highly, highly recommend is even if you're using a calculator, don't put the numbers as decimals because you'll completely miss the patterns if there is this decimals. Right? We're really going to really try to focus on patterns in this process. Okay, so the first thing we need to do is we need to get something that looks like this pattern of x squared plus bx or x squared minus bx. Okay, so that means this 4 can't be here, right? We're probably going to want to move the 17 over here. So to do that, let me go ahead and move the 17 over. Now some people will leave it over there. It's fine. It's not wrong or right. You just have to follow the rules of algebra. Okay. Now I'm going to divide by 4. So we divide by 4. X squared plus 5x equals negative 17 over 4. So now we have what we want, this x squared plus bx. We have something of the form that we should be able to complete the square. That's what this is called here. And the number that completes the square is always this piece right here. This piece will complete the square, this b over 2 squared. So b in this case is 5. Right? So to complete the square, we're going to take 5 over 2 and we're going to square it. This is where you don't want to type it in your calculator. We want to actually take 5 over 2 and square it. And that gives us 25 over 4. A nice number that we can work with. So for that, once I know this number, I need to get a 25 over 4 on the left-hand side. And I know that if we add something to the left, we have to also add it to the right. So our next line will be x squared plus 5x plus 25 over 4, and then negative 17 over 4 plus 25 over 4, right? Because what we do to one side, we have to do to the other. We have to keep this even. Now, the reason I wanted this setup here is that this is a binomial squared pattern, right? This will always factor, because here it was a plus in the middle, it'll factor to be x plus b divided by 2 squared. Well, we know b divided by 2 is 5/2, because we just had it right here. So this is, left side is going to factor to become x plus 5 over 2 squared. This right side will become 8 over 4, which is just 2. And just to confirm here, right, if we think about our binomial squared, you have x squared, right? 2 times x times 5 over 2, which is 5x, and then 5 over 2 times 5 over 2, which is 25 over 4. Okay. So now at this point, does this look like a square root problem? Yeah, completing the square is just writing it so that we can use square roots. So now at this point, we'll square root both sides. And that's going to be plus or minus radical 2 on the right. So x plus 5 over 2 is plus or minus radical 2. I'm just going to subtract minus 5/2 from each side. So x equals negative 5 halves plus or minus radical 2. And those would be our two answers. I'm probably not going to plug that in by hand and try to check it because it doesn't seem like a lot of fun. But if you wanted to, you could store this as a decimal. Store one of them, right? There's actually two numbers here. You could store one as a value and plug it back into here to check it. So that's the completing the square process. Okay, let me let's maybe take a minute and try one. So let's try 2x squared plus 12x plus 3 equals 0. So if you want to take a second, try that one, and we'll come back and look at it. Okay, so for this example, again, we're going to want to isolate get x squared plus some number. Right, so let's go ahead and subtract 3 from each side. Divide everything by 2. So x squared plus 6x equals negative 3 halves. Now, this is the number this is b, correct? This is where we have to complete the square. So we're going to take b divided by 2 squared. So again, b divided by 2 squared is going to be, that looks like a 6. That would be 6 divided by 2 squared, which would be 9. So we need to add a 9 to both sides. So x squared plus 6x plus 9 and negative 3 halves plus 9. Now the left side, this is just a binomial squared, right? It's x plus 3 squared. Over here, this is like 18 halves, isn't it? And you take away 3, that leaves us with 15 halves. Rationalize a denominator. So anyways, let's square root both sides. So x plus 3 equals plus or minus the square root of 15 over 2. Now we really don't love having a radical 2 in the denominator. So let's go ahead and multiply the top and the bottom by the square root of 2. Thinking back to the other couple weeks ago with rationalizing. So x plus 3 equals plus or minus radical 30 over 2. We rationalize the denominator. We'll subtract 3 from each side. So negative 3 plus or minus radical 30 over 2. You could do that, but again, remember that's actually two different answers. So you also, I don't know if on Delta Math or on how it wants you on the My Math Lab that I have out there, it might have you write it like this for the answer as well. Which isn't, which is equivalent. Did we all get that? Is that good? Okay, the last of our 4 methods that we should be able to use to solve a quadratic equation should be the quadratic formula. This is derived from completing the square of ax squared plus bx plus c equals 0. So if we do that, it's fun to try if you're interested to try to take just using these coefficients of a, b, and c and try to do the whole completing the square process. You actually will get the quadratic formula. A little bit of creative repositioning sometimes, but it's doable. This should be something you know, like everyone should know the quadratic formula. Like I shouldn't have to tell it to you. It's over here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But again, that's something any math class you take from now on, I'm sure your teacher's going to assume that you can solve that. And really, after completing Algebra 2, we should be able to solve every quadratic by hand using one of these 4 methods. So, notice the quadratic formula only works if it's in this form, right, where it's equal to 0. So our first step is 3x squared minus 6x minus 5 equals 0. And then if it helps, you can identify a, b, and c. Some people like to do that. So here a would be 3, b would be negative 6, c is negative 5. and then I'm just going to go ahead and plug into the formula. So it's the opposite of b. So if b is already -6, that would be 6. And then we get b squared. So I'm going to write -6 squared, but if I'm working on my own, I just put 6 squared because I know that anything I square is going to become positive. So the negatives doesn't really need to be there. But I put it there. That is the formula. And then, so it's all under a single square root. So this is b squared minus 4 times a times c. And that's all over 2a. I know there's this song with like Pop Goes the Weasel. I know the end is all over 2a, but that's all I know. So, but let's see what we have here. So this is going to be 6 plus or minus 36 plus, because we have a negative. So what I'll do here is this is always a -4, right? So it's -4 times 3 times -5. I see 2 negatives, so I know I'm going to add something. That's 12 times 5, which is 60. Over 6. Now, you're not allowed to cancel the 6's out at this point because you have that addition subtraction. Right? There's 2 terms on top. If there's multiple terms, canceling is usually not going to be an option. So now at this point, we could say x equals 6 plus or minus the square root of 96 all over 6. Having a square root here, we should see if we can simplify it. And I know that 16 times 6 is 96. So we need to simplify that. So we'll get, go over here. We could say x equals 6 plus or minus radical 16 times 6 all over 6. Just simplifying a radical. 6 plus or minus 4 radical 6 all over 6. So again, the square root of 96 is equivalent to 4 times the square root of 6, and that's why we practice rationalize those. Here at this point, kind of 2 ways you could write it here. We need to simplify it a little bit further. Some people will just write it as, they'll just take each thing in the top and write it over 6. So you could say x equals 6 over 6 plus or minus 4 radical 6 over 6. And then you could say x equals 1 plus or minus 2 radical 6 over 3. That's fine to write it that way. Perfect. An alternative way to write that is if you have this x equals 6 plus or minus 4 radical 6 over 6, is I could just look at each of the 3 terms, ignoring what's in the radical, because it's not going to simplify anyways. But I see they're all even, right? They all have a factor of 2. So what you could do here is you could say, well, that's 3 plus or minus 2 radical 6 over 6. Again, I just factored a 2 out of the top. And then 2 and 6 will reduce to just put a 3 on bottom. So you also could say 3 plus or minus 2 radical 6 over 3. That would be a way you might see it too. But these mean the same thing. Because if you look, if you did just do 3 over 3, you'd get 1. If you did 2 radical 6 over 3, you'd still get 2 radical 6 over 3. You'll see them both ways. Either one's fine. This is not simplified, though. This is definitely not simplified if you have a 96 in here, right? That would be a problem. We do want to give exact answers on these. It's fine if you want to approximate it to check it or even include the approximation, but we want to leave the radicals in here. Because as we'll see next time with our calculators, if you need an approximate solution, just use a calculator. Like you don't have to do any algebra. I'll show you how to use the graph to find the answers.